In this video, we'll discuss the last question on the Alkene addition lab. Was your synthesis successful? Explain using FTIR and melting point data. So I'm going to focus on FTIR. We'll take a look at the reactant, cinnamic acid. I have the FTIR on the left here, and then the product, dibromohydrocinnamic acid, here on the right. As you can see, I've drawn both structures on the FTIR and the corresponding FTIR. So let's take a look first at the reactant and just look at the functional groups, and then we'll compare to the product. And we'll ask questions like, is this functional group still present? Should it be present? And if it's not, why did it disappear? So first, let's take a look at our reactant. So first thing, when I look at the structure, I can recognize this carboxylic acid, or COOH. And if I flip over to the important IR peaks, I can see it right here from 3,300 to 2,500, and we see that it's strong and very broad. So knowing that, let's flip back, and I can look from 3,300 right around here, maybe a little farther, and 2,500, it's right there. So if I look up in my FTIR, I see a very broad peak. Not necessarily extremely strong compared to something such as a CO double bond. However, it is very broad, so that's distinct, and we can label that as the carboxylic acid there. And then if we look over at our product, we can ask the question, does our product have a carboxylic acid? And if I look at the structure, I see yes. We still have that COOH bond, indicating that that is a carboxylic acid, so we should see it in the FTIR. So let's look from 3,300 to 2,500. I see a very similar peak to our reactant, very broad, and between that range, so our carboxylic acid stayed across the reaction. Next, I see a benzene right there. And if we flip over to our table, here's our benzene from 2,000 to 1,650, and we know that it's teeth and weak, so very distinct characteristic there. So flipping back, I can see from 2,000 to 1,650, right around there. If I look up, I see those teeth, and it's very weak compared to the other peaks on this spectrum, so that is a key point to look for. And now let's look at our product. Do we have a benzene ring? Yes, we do in the structure. So we should see that show up on our FTIR. So make sure you check. Does your product FTIR have benzene? Have those like weak teeth? So let's look again from 2,000, 1,650, somewhere in there. And it is very, it is a lot smaller, but we can still see those teeth there, and they're just very weak. But we can still see the presence of that aromatic functional group. So that's great. We expect to see that. And be thinking, if you don't have these functional groups, the ones that you should see or you expect to see in the product, why? Why did it not show up? That could be something to include in your paragraph. Next, I see a CO double bond, part of that carboxylic acid, but its own functional group as well. So let's flip over and find it on our table. I see it right here from 1,780 to 1,650, and it is strong. So let's head back. 1,780 about here, 1,650 about here. If I look up, I see this very strong peak right here, and it's labeled for you, so that's great. And that will be our CO double bond in our reactant. So now, looking over at our product, do we have a CO double bond? We have a carboxylic acid, so the answer is yes, we have to have that CO double bond. So 1,780 to 1,650. If I look up, there it is. Very, very strong, very distinct CO double bond. So that is what we expect, and that's what we see, so that's great. The last one I want to talk about here is that carbon-carbon double bond, or our alkene, that we have in our reactant. There it is. That's what we use for bromination. So we do expect to see that in our reactant. Let's flip over here. I added it in to our table because it wasn't there before, but here's our carbon-carbon double bond. about 1600 roughly. So let's flip back over and we look about 1600. And it is difficult to see because it's pushed up against that CO double bond, but we have a peak right in here that represents that carbon-carbon double bond, our alkene. So that's important to be able to recognize in the reactant. But then if I look at my product, I no longer have an alkene. I have that CO double bond, but we've already identified that as its own functional group. So now I'm looking for that carbon-carbon double bond, right? And I don't see that anywhere. So that means that we should not expect to see that on that functional group on our FTIR. So now if you look at your product and you see that carbon-carbon double bond peak, what does that mean? It would mean that there is still reactant material in your product, which would indicate an unsuccessful synthesis. So keep that in mind. Make sure you talk about that in your paragraph if you see that, and just really pay attention to the similarities and differences between the reactant FTIR and your product FTIR. Thank you for watching, and make sure you ask your TAs if you have any questions.